In this video, we're going to look at motion and mechanics. There's going to be a few questions on energy calculations and also a little bit on Suvat. So just to start with, it tells you a snowboarder is sliding down a slope. Between B and C, her acceleration is uniform. Uniform is just another word for constant, meaning that we're probably going to have to use Suvat for the motion between B and C. The snowboarder travels 1.5 meters from B to C in a time of 0.43 seconds, and her velocity at point C is 5 meters per second. So since it's giving you quite a few variables between B and C, and as well as giving you that its acceleration is uniform, you can use Suvat here. If we think about the motion, actually I'm going to do it here, where there's more space. If we think about the motion specifically from point B to C, we know there's a constant acceleration that we don't yet know. With Suvat, you always want to have 3 known variables and 1 unknown variable. In this case, we're starting our motion at B, so that means the initial velocity is the velocity that we want to find, because we want to find the velocity at B. Our final velocity is where we're taking the motion up to, which is up to point C. And the velocity at point C, it mentions, is 5 meters per second. So V is 5. It tells you that a time of 0.43 seconds is taken for the whole journey between B and C. It's also told you the whole time taken for the whole journey. The whole distance of the journey, which is 1.5 meters. Now that we've got 3 known variables, S, V, and T, we can use them to find the value of U. Which equation links S, U, V, and T? It's actually S equals a half of U plus V, all multiplied by T. Let's substitute into that equation, and we can do the rest of the work out here. So I'm going to replace S with the displacement that's moved. 1.5 is equal to, actually I'm just going to change the thickness of the pen too. It's equal to a half of U plus V, which is U plus 5, all multiplied by the time taken for the journey between B and C, which is 0.43. A half of 0.43 is, well, it's 0.215, and then in brackets U plus 5. From here you can divide both sides by 0.215, so we get that 1.5 all divided by 0.215 is actually equal to U plus 5, and then we can subtract 5 from both sides. When we do that, we get U is equal to, well, 1.5 divided by 0.215. That looks like a decimal point. Sorry about that. If we do that in our calculator, we'll get a value of something around 7. And then if we do 7, take away 5, we get a speed of 2, or 1.98 meters per second to be a bit more specific. Yeah, I sped through that rearranging a little bit quickly because I'm sure you guys know how to rearrange. Let's now move on to B part I. It tells you the combined mass of the snowboarder and snowboard is 75 kg, and the angle to the slope is 25 degrees. Calculate the component of the weight of the snowboarder and snowboard acting down the slope. Acting down the slope is in this direction here. The weight acts vertically downwards, I'm sure you guys know that. So the component of weight that acts down the slope is this component here. What I'm hoping you guys are seeing is that it forms a right angle triangle with this sort of component perpendicular to the slope. Let's draw out that right angle triangle. We know that this angle here is 25 degrees, the angle between perpendicular to the slope and also the weight. Now the weight itself is found by doing mg, which is the mass of the combined snowboarder and snowboard, multiplied by 9.81. I'm just going to quickly do that on my calculator. So 75 multiplied by 9.81 is equal to 735.75. Okay, 735.75. And what do we want? We want the horizontal component, this component here acting down the slope, which corresponds to the horizontal component of this circle. Well, if this is a right angle triangle and we want to find, let's say, x, we're going to use the opposite and the hypotenuse. So we can use SOHCAHTOA and sine in specific in this question. We can say sine of the angle 25 is equal to the opposite component, which we're trying to find. Let's replace that with an x, all divided by the hypotenuse, which is 735.75. From here, you can multiply both sides by this denominator. So x is equal to 735.75 multiplied by sine 25. Put all of that into your calculator and you get a value of, let's see, 311 newtons. Let's now use this to do this bonus question that I put on the board. It tells you between D and E, the snowboarder has reached a constant velocity. That's important. She moves a distance of 2 meters at constant velocity between D and E. Calculate the work done against the resistive forces as she moves from D to E. Well, the fact that she's moving at a constant velocity means that, well, at this point, the energy that's being used due to the weight pushing that person down is being balanced by the energy or the work done against the resistive forces. So we can find the work done against the resistive forces by taking into account the energy due to the weight. So how do we calculate the energy due to the weight? Well, we can find the work done created by the weight because we use the force and we multiply by the distance. Now, what force do we use? Well, we use the component of the force that acts in this direction, which is the component of the weight that acts in that direction that we've already found, 311. And we multiply that by the distance between which it moves at that constant velocity. That's 2 meters, and that's equal to 622 joules. That's the work done by the weight pushing the person downwards, and that's also the work done against the resistive forces, so that the energy can be balanced out in both sides and it can move at a constant velocity. If there was more energy going downwards, then it would accelerate, it would speed up, it wouldn't move at a constant velocity. Hopefully that all makes sense. This part specifically was quite difficult. If you do need to, you can replay it, but thanks for watching, and yeah, be sure to like and subscribe. I'll post more content like this very soon.